Okay, in this video, we're going to go over how to graph one variable inequalities using what's called interval notation. And I have three different examples for you. You really should watch the introduction to inequalities before you actually do this one, okay? Introductions part 1 and 2. But let's just get started with this one. So we recognize there's only one variable. So the graph of this is going to be simply a number line, isn't it? Okay, so let's just draw a little number line to get us started. And let's go ahead and solve this as we know how to do. Now, step 2. We're going to isolate the x by subtracting 1 from both sides. And that's going to give us negative 2x is less than 2. Then we're going to divide both sides by the negative 2. And remember that when you divide by a negative number, divide or multiply, you need to flip the direction of your interval, of your inequality, right? So this is going to give us x is greater than negative 1. Now let's go to our graph and let's graph x is greater than negative 1. We see that the negative 1 is right here, so we'll just put that there. And then we have to start recognizing now what the actual inequality is. And in this case, it's just a greater than. There is no equal to. So with just greater than, we are going to put an open circle around the negative 1. Because if we did put negative 1 in here, we would see that this would not be a true statement. Now we're going to follow the direction of the arrow. So we're going to go up this direction and we're going to shade in the greater than area. And if we wanted to make sure that this was correct, we would just take a test point. Let's just choose any point here. Let's just choose like positive 1. Okay, and let's just insert it here. So we'll check it. We'll go negative 2 times positive 1 plus 1 should be less than 3. Let's see if that is true. That gives us negative 2 plus 1 is less than 3. It just gives us negative 1 is less than 3. So that's a correct statement. We know that that's correct. However, we're not still done with the interval notation. Now with interval notation, we're going to start going left to right. You start at the far left-hand side of the graph, okay? Left-hand side of the graph. So you really need to draw the number line of the graph, okay? And we see that it's at negative 1, so we'll write down negative 1. Then you go to the exact opposite side, the far right-hand side. Far right-hand side. And we see that it's a positive infinity. So I'm just going to go comma, because that's how you separate the left and the right. Positive infinity. So I'll just do one of those infinity signs. Now, in the next step, we need to use brackets or parentheses. If my number includes the far left-hand side, like let's say this word filled in, then I would use a bracket. Since it's including everything up to but not including negative 1, I'm going to use a parentheses. So in this case, I'm going to do a parentheses. In this case, on the far right-hand side, same idea. If it stopped at a particular number and included that number, I would use this. If it goes on to infinity or doesn't include any specific number, I use that. So I'm going to close it and do that. This is called an open interval. Okay? Because both sides are open. All right, and that would be the interval notation for this particular problem. Okay? Let's try another one. In this case, we have another interval, but we see there's almost like there's two problems here, right? So we're going to break this out into two different problems. We're going to break this out. Let me just do it that way. We're going to break this out into 3 is less than x, and x is less than or equal to 5. So whenever you see something like this, where the unknown is in the middle, break it out, cover up one side, write that out, cover up the other side, write that out. Okay. Now, for the sake of argument, just because I like this, I'm going to flip this around and just say x is, use the open side towards the x, is greater than 3. Okay? Now, there's no solving here because we already have our x on one side and it's isolated, but we can graph it. So this is what we're going to do. There's my single number line. X is greater than 3. 1, 2, 3. So no equal sign, so I use an open circle, follow the direction of the arrow, and go in that direction. Go ahead and shade. My other one is x is less than or equal to 5, so let's go 4, 5. Less than or equal to means I fill it in, follow the direction of the arrow, and I go down in this direction. Okay? And then graph. Now I should probably just use a slightly different color here, but give me 1 second. And if I were to graph just that part here, it would look like that. Okay? There we go. Now what you see here is that there's an overlap here, isn't there? It overlaps where the red marks are and the green marks are. So my answer in interval notation would be this, between 3 and 5, because those would be all the numbers that would work for both of these equations. So between 3 on the left side, 5 on the right. Remember, put the parentheses. Since this is an open interval, remember you use the parentheses. Since this is a closed interval because it stops at 5, you close it off. This is called a half open interval. Right? Because only half of it is open, this end here and not this end here. And this is the interval notation for this answer. All right, now let's just do one more example here. Okay, now in this problem, we have the words or. And I'm going to save the, I'm going to actually do this problem. I'm going to save the explanation for a different video. So let's go ahead and try this one. I can graph it right off the bat because I know that x has to be greater than 2, open, right? Because there's no equal sign, so I put an open dot, follow the arrow, there it goes. Let's go ahead and shade in every number here, like 3, 4, 5. For example, like x is 3 greater than 2? Yes. Is 4 greater than 2? Yes. So all the numbers over here are greater than 2. It's a check. But we also know that x is less than 0. So we'll do this. We'll put a circle around the 0, -1, -2, -3. Follow the direction, right? Going in that direction. So we go this way. And then go ahead and graph these. Now, this is where the interval notation gets a little bit tricky. Essentially, we've got two answers here, don't we? So let's just do this one first. You start left to right. The left-hand side is a negative infinity because it just keeps on going. So I'm going to put negative infinity, then comma. The far right-hand side is 0. Let's do this one. The far left side is positive 2, comma. The far right-hand side is a positive infinity. We don't normally put the plus there because we just assume that it is. Now let's go ahead and put in our parentheses or our brackets. In this case, we know that it's an open interval because it keeps on going. It goes up to but doesn't quite include 0, so again, we have to keep it open. Same thing with 2. It doesn't include 2, but it goes up all the way to 2 in this direction, right? And then it keeps on going forever in that direction. Now, the answer really is every number that is in here and in here, but not in the empty space. So you would use this symbol called a U, which means union. If we put these two answers together, we would have the interval notation for this particular problem. Okay? And like I said, I'll explain this part in another video. Okay, good luck to you.